What derivatives tell us? Part 1. Derivatives tell us whether a function is increasing or decreasing. If a function is increasing, its derivative is positive. And if a function is decreasing, its derivative is negative. So increasing goes hand in hand with a positive derivative, and decreasing goes hand in hand with a negative derivative. And so we use derivatives to find for where a function is increasing and decreasing. And what we do is we follow these steps. The first thing we do when we have a function and we want to know where it's increasing and decreasing is we think about what its domain is, and we look for its critical points. This function is a polynomial, so its domain is all real numbers. What are its critical points? Well, remember that a critical point occurs if the derivative is 0 or the derivative does not exist. This derivative exists everywhere. Its derivative is equal to 0 when x is 0 or negative 1. So the derivative of the function defined everywhere. The derivative of the function is 0 when x is 0 or negative 1. We use the domain and critical points to create subintervals. Then, on each subinterval, we're going to determine the sign of the derivative, because remember, the sign of the derivative tells us if the function is increasing or decreasing. So on each subinterval, what we do is we find a test point. So for example, on the first interval, I would use a test point of -2, and I would see is the derivative at -2, is it positive or negative? So that's what we're going to do. For the first interval, I choose a test point of -2. The derivative at -2 is positive, and that tells me that my function is increasing. Okay, how about a test point for my second interval? Well, I could choose -1/2 because that's between -1 and 0. Notice at -1/2 the derivative is negative, and that tells me that my function is decreasing. And for my third interval, I choose 1, and my derivative is positive, telling me that my function is increasing. After finding where a function increases and decreases, we can use that information to find local minimums and local maximums. If a function goes from increasing to decreasing, you have a local maximum. If a function goes from decreasing to increasing, then you know you have a local minimum. This is called the first derivative test for determining if a critical point is a max or a min. Let's go back to our example. Going from the first interval to the second interval, I go from increasing to decreasing. So at my first critical point of -1, I have a local max. Going from my second interval to my third interval, I'm going from decreasing to increasing, and that tells me that at my critical point 0, I have a local minimum. Notice that the derivative only tells us about the behavior of the function, not its specific values. It doesn't tell us whether the function is positive or negative, or where it's located. It only tells us where the function is increasing, where it's decreasing, where it has a local max, where it has a local min. Notice that this cubic function is always increasing, and this is confirmed by the fact that the first derivative is always positive for all values of x. Suppose we would like to discuss how the function is increasing. Notice that the shape changes from a cup facing down to a cup facing up. When a graph bends downward, we say that the function is concave down. Look at the tangent lines as x approaches 0 from the left, moving in a positive direction. So that's moving left to right. The tangent lines start out steep and get flatter. Now also, if you take the second derivative, you'll know that approaching 0 from the left, so x is always less than 0, notice that the second derivative is negative. A negative second derivative means that the slope function f prime is decreasing. So I'm talking about the derivative of the slope function. So the derivative of the slope function tells me that the slope function is decreasing. And this is in keeping with the fact that as we approach 0 from the left, the tangent lines are getting flatter. When a graph bends upward, we say that a function is concave up. Look at the tangent lines as x leaves 0, continuing right in a positive direction. Now these tangent lines start out flat and get steeper. Notice that the second derivative is positive. So when the second derivative is positive, we're talking about the derivative of the slope function. The derivative of the slope function is telling us that the slope function is increasing. And this is in keeping with the fact that as we leave 0 moving right, the tangent lines are getting steeper. And so the second derivative tells us whether or not my slope function is increasing or decreasing. But another way of saying that is the second derivative tells me about the shape of my function. And so here's what we do. We say that if f double prime is less than 0 on an interval, then f, the function f, is concave down on that interval. And that's just because the slope function is decreasing. If f double prime is positive on the interval, then the function is concave up on the interval. And that is because our slope function is increasing. It's kind of cool. Now, if x is a point where f double prime is equal to 0, and if f double prime changes sign, and so I'm going from concave up to concave down or concave down to concave up, when that happens, when I change concavity, then x is called an inflection point. To determine concavity and inflection points, we're going to follow these 4 steps, and we'll do an example in part 2. I'll see you then.